Hi, I'm George Crump, lead analyst with Storage Switzerland. A lot of enterprises have decided on virtualization as the way that they're going to really run their data center, which makes sense for a lot of reasons. And as you think about that, though, the storage infrastructure plays a real critical role in how well you can see a return on that investment. The problem is you have a lot of options available to you in storage, and sort of, you're trying to decide and understand which is the right one for you, I think can be a challenge at times. Well, Tintree is one of those options, and so to talk about why they might be the best option for you, I've invited Steve Phillips with Tintree to join us. Steve, thanks for joining us today.
You're welcome.
So I guess, why does Tintree exist? What makes it better than the other solutions on the market, in your opinion?
So Tintree was designed from the ground up to be a storage appliance designed specifically to handle virtual workloads. We don't really do anything else.
Okay.
And so as a result, there's a lot of intrinsic design decisions that we made up front to make sure that we're serving that particular purpose well.
Okay, well, let's talk through some of those.
Sure. So one of the most common ones is, what do you do if you've got a set of data stores that service virtual machines? Now, virtual machines, we can all agree, are just a bunch of virtual disk files and a bunch of metadata.
Right.
Right?
Sure.
So at the end of the day, they're just put into these containers called data stores.
Okay.
The problem with traditional storage is those containers cannot be viewed by the storage device. They're typically done through SCSI calls,
right,
through SCSI read 10, write 10.
Sure.
And so the storage device has no idea what's inside.
Yeah, it doesn't have that visibility into it, right?
That's right. And,
okay,
and so the really main design goal that we had was we want to be able to understand what those virtual machines are inside of those containers, right?
Okay.
So we've drawn here a couple of examples. So there's some different workloads that are running on here.
Okay.
The problem with traditional storage is they act kind of like a funnel. So the storage device sees what comes down the pipe,
right,
and it makes the best effort to try to figure out what to do.
Okay.
Right? What we've done is something a little bit different. So
okay,
because we use a file-based protocol, we can see and understand every I/O that comes in, and we know exactly what virtual machine it's meant for.
Okay, so you've got it like an end-to-end map then of
that's
what's
correct.
going on. Okay,
that's correct. So we
okay,
have very tight integration with the hypervisor managers like vSphere, Hyper-V, RevM, the major ones that are
okay,
out there. Right?
Okay, good.
But because we have a file-based protocol, as I mentioned, and we're using NFS for the most part, we use SMB for Hyper-V, but we can understand exactly what those VMs are,
okay,
and we can also react as things change.
Okay.
So for example, here, we can make sure that we understand not only the squares, the circles, et cetera, but when you start adding additional VMs in here, like a triangle workload, for example, this could be something that was unexpected, and this is something that we get a lot.
Sure.
So in the virtual world, you get something that's unexpected, you typically have to have a human being get involved and try to figure out what's going on, troubleshoot. In this kind of environment, the instrumentation is not there. We'll talk about that in a minute.
Okay.
But in our world, those VMs come in here, and we understand immediately what they are, and we can react accordingly. So if this guy comes in and says, I want 1 million IOPS from my triangle workload, mm-hmm, in this environment, what's typically going to happen is the squares and the circles are going to get squeezed out, and a human being has to get involved and say, what's going on?
Right, sure.
But they can only see something in terms of a volume or a data store. They don't see the individual VMs necessarily from the storage point of view.
Well, and I think another challenge that I see a lot in that environment is that human being getting involved, it takes them a long time to diagnose what just happened, because in a virtual world, things can spin up and the guy that's in charge of storage may not even know that whatever just got spun up happened, right?
That's correct. I call that the finger pointing paradox.
Yes, yes.
Right?
Mm-hmm.
So he starts talking to the virtual guy says it's a storage guy's problem.
Right.
Right?
It's always the storage guy's problem.
Of course it's always
yes,
the storage guy's
yeah,
problem. So the storage guy in this case can say, well, you know what? It may not be my problem.
Right.
And here's why. Because I understand exactly what's going on, mm-hmm, right? But the storage device, more importantly, can then automate its response.
Okay.
So in this case, if I say I want 1 million IOPS from Triangle, I can give him as many IOPS as I want, but then I'm going to give him just enough where he does not interfere
Gotcha.
with the squares and the triangles. And that's using queue depth management and so forth, automated.
I don't know if you did this on purpose, but this reminds me of swim lanes, right? We've organized it if you're doing laps, right? These are like swim lanes.
That's
right?
a great analogy. So stay in your lane is a great phrase, right?
Okay.
So in this case, then we can if he becomes a bully VM, if you will,
okay,
we can then adjust those queue depths to make sure that he's not interfering with the other guys.
Okay.
Right.
Okay.
So now this leads to the next step, which is instrumentation.
Okay.
So in this case, I have a certain set of instrumentation to know, how busy is my LUN, how busy is my volume, et cetera. I get a little bit of rudimentary information about it.
Sure.
IOPS, latency, et cetera.
Mm-hmm.
In this case, we're changing the level of granularity for this instrumentation. So in this case, now I'm getting instrumentation based on the virtual machine,
right,
not based on the data store or the volume.
Gotcha. Okay.
So as an administrator now, I know exactly what's going on, and I can say, oh, I need to do something about this, or even better, the automated features that we provide do that for you.
Now, just to clarify, that instrumentation, is that an extra charge that I have to do when I'm getting the Tintree system?
No, this is all
okay.
built into the system. So we give you things like, we give you IOPS, obviously. We'll give you latency statistics. And because we're so tightly coupled with the virtualization estate, we can give you latency based on not just what we're seeing on the storage array, but based on queuing at the host level, queuing at the network level, right? So again, the finger pointing paradox, we know exactly who to go talk to.
Sure.
And this is all visually presented.
Yeah.
Right?
Well, and there are tools that kind of do this, but probably don't have that level of granularity, and the additional expense is obscene almost.
Correct. And a lot of times it's maybe 4, 5, 6 tools.
Right. Yeah.
Now we've managed to get all of this in one stack, so you know exactly where to look. And then we've taken that to another level. So what happens now is you're able to get these statistics and this instrumentation on a per VM basis. So not only is it IOPS, latency, et cetera, but we also provide additional per VM features such as snapshots. So in the traditional world, if I'm taking a snapshot of this volume, I'm not taking a snapshot per VM. I'm taking the entire volume, and maybe I have to extract that VM data out of it, right? And there may be additional changes that I don't care about. In this case, I'm only capturing the VM that I want, right? We also have things like replication. So if I want to take that and move it to another site, I can easily do that on a per VM basis. Recovery and backup to the cloud, for example. We can take that and back up to any S3 compliant storage object store.
So that granularity allows me, I would assume, to number one, set separate schedules for different VMs, because different VMs will have different levels of importance to me.
That's right.
And I may not, for example, want to replicate everything to a DR site because they might be sort of test dev VMs or something like
Correct.
that. Okay.
Correct. And we have service groups that can do that on a per folder basis, on a naming basis, whatever makes sense.
Okay.
And then those automatically get inherited as we go along.
Awesome. Okay.
Great. Now, that is true that you can get some of this instrumentation with other tools. They can tend to be very complex, but they tend to be at a totally different granularity. So they can be on a per LUN basis, et cetera. So one of the other issues that comes up is, well, if I'm creating a bunch of these LUNs, and matter of fact, I was reading through the VMware storage best practices because I'm that guy. And on page 37, they talk about how many LUNs to use.
That was page 37.
Page 37, that's correct.
All right, just want to make sure I got that.
I'm that guy.
Yeah.
So as I was going through it, it said you want to make sure you've got enough LUNs or enough volumes to make sure you're spreading out the I/O correctly. But in the very next paragraph, it talks about you don't want to make too many because it can saturate the array queues at the storage side, right? So as an administrator, I'm looking at that saying, well, okay, well, what do I do, right? So then so not only do you have to make a decision about how many you want to do, but then you have to make a decision about how full and how big you want to make each one of them.
Right.
And so this adds another layer of complexity into the arena, because now you've got a bunch of free space that you can't necessarily share among these different volumes. We present our data store as one big pool of storage. So the goal here is to make sure that you've got as much automation as possible to make sure that you can share all of that storage space among one large volume, instead of having to make constant decisions about how things change and how to fill up these volumes individually.
Well, I assume there's also just sort of a basic capacity efficiency here too, right? The more I carve things up, the less efficient I become just in the way I consume my storage capacity.
That's absolutely correct. And because we've made the design decision to use a file-based protocol, it's thin provision by default. So you get all those storage savings for free.
Makes sense. So Steve, thanks for joining us.
Thanks for having me.
So there you have it. If you're looking to invest in a storage platform specifically for the virtualized environment, Tintree is a really good option for you. It gives you a lot of capabilities. This granularity and control at a VM level is going to not only allow you to really grow that and really deliver a complete ROI from the environment, but also just be more efficient in how you use it, and also drive down probably operating costs. I'm George Crump, lead analyst with Storage Switzerland. Thank you for joining us.